All right, thank you everyone for coming today. As you see, I'm going to talk about permissions in Postgres, also known as privileges. I'll probably use both words interchangeably. I'm going to talk first just about how to look at and set permissions. I'll talk about a couple things that aren't permissions that maybe you'd think they were. Then I'm going to go over each of the objects in Postgres that has permissions and go over them. You can get all of this, of course, with the grant command and reading the documentation for that. But the grant command documentation talks about each permission. Like it'll say, here's what select will do on all the things that select will affect. Rather, I'm going to talk about, here's all the things you can do to a table or schema and so forth. I'll talk a little bit about setting up a read-only user. Very briefly on how roles can inherit permissions from other roles. We'll talk about security definer permissions and then defaults. So, getting right into it, in PSQL, the basic way to look at permissions is the \dp command. And here we have an example which is right out of the documentation for looking at permissions on a table called myTable. The interesting column here is the third one. And that's where you can see we have access privileges, and the first line there is Miriam equals, and there's some alphabet soup, and then / Miriam. And the way to decode that is that shows the piece before the equals, the Miriam, is what user these permissions apply to. So if you're connected to the database as the user or role Miriam, these are the permissions that you're going to have on this table. And then the alphabet is each letter encodes one possible permission. And the / Miriam shows who granted those permissions to the user Miriam. And in this case, Miriam has granted the permissions to herself. And that is essentially intrinsically what happens whenever an object in Postgres is created. The user is considered to have granted itself all of the permissions available for the object. And in this case, the A, R, W, D, X, T are all of the permissions on a table. The next line, the equals /r or equals r / Miriam, that is because there's no username. Those are the permissions which have been granted to public. So if there's no username, that means public. And public is sort of I mean, it's a user, but it's a pseudo user that has special things. It always exists. Certain rights that public has are implicitly available to every user on the system. And then in the third line, we can see where Miriam has granted 3 permissions to a user named admin. And that just shows, again, what it would look like where you're granting permissions to a role that isn't you, as it were. The last column, column access privileges. I'm not going to talk a whole lot here about column privileges, but in general, for tables and so forth, well, tables and things that are like tables, views, and foreign tables, you can grant permissions not to the entire table, but only to specific columns within the table. So if you have a user that perhaps you want to be able to see, say you have an employees table, you might want a user that logs in to maybe see their address, but not their salary, for instance. And you could use column level grants of access privilege to achieve that as well. And that fourth column shows the privileges that have been granted specifically to column 1. Yeah, I'm not sure why that keeps cutting out on us. All right, here are just for immediate reference, and this is in the documentation for the grant command as well. But you can see how each possible privilege that exists within Postgres has a letter. And you'll note, say, with delete and truncate, that those are case sensitive. That shows then when you look at the privileges, you can see that, for instance, Miriam has granted select, the R, read is the mnemonic, permissions to public, and insert, read, select, and update permissions to admin. Not all objects have all privileges. Execute, for instance, is only applies to functions, no other objects. Yep. Why? That is flaky, isn't it? There we go. All right. Granting permissions. In order to grant permissions, you use, surprisingly enough, the grant command. Here I have an example of the syntax for granting permissions to a table. And the syntax is pretty much grant and then just a comma-separated list of whatever privileges you want to be allowing. Or you can also say all, or all privileges. Privileges is an optional noise word. And that just grants all of the available permissions, in this case, say on a table, to someone. So just here, full access, here you go. In addition to specifying the individual table name, Postgres, and I think this is 9.5, 9.4 Postgres, that's relatively new for some of these, that instead of saying on, say, table foo, you can just say, I want to grant this permission to all tables that exist within a schema. And this can wind up being really handy if you're needing, you have a new user or you're doing some kind of blanket thing, rather than finding, I've easily seen, things of hundreds or thousands of tables, but they're usually collected up in a relatively small number of schema. And it's a lot faster to write the commands out to just say, okay, I need this for everything in, the accounts receivable schema or whatever you happen to have. And you have to specify here, you can see to role specification. You have to say who you're giving the privileges to. And the option there is either a role name, and roles, groups, users, really all mean the same thing in Postgres. They're the same kind of thing. What the difference between, say, a user and a group is really just how it's been set up. Typically, creating a user, you think of that as something that can log in and do stuff. A group are things, is the type of thing that, typically, it's not going to log in directly, but rather individual users will be members of the group. But from within Postgres, there's no actual distinction between users and groups. In addition to specifying a particular role, you can also say public, and we saw that earlier where we had the permissions to public. I forgot to start my timer. And we saw that earlier. Additionally, you can specify current user or session user, and I'm not going to get into those in detail, but Postgres keeps track of the notion of the current user and the session user, and that could be, it's really out of scope for this. I don't think I've ever actually even seen anyone do that. But it's kind of grant permissions to myself. Sorry, go ahead.
Yeah. When you do grant all tables, that only applies to tables, or can you also make it applicable to functions?
You can do. I'll cover the functions in a little bit. So.
When you can grant all tables, that's all tables that exist at that particular point in time.
That's correct.
If you add foo2 later on, it's really not all tables. It's all. You'd have to do another grant.
You would. You can also get largely the effect of that by altering what are called the default permissions that everything gets, and you can do that by schema. I'll cover that a little bit later.
Internally, it I guess turns into individual grant privileges of all tables that exist.
Effectively, yes. You'll notice at the end here, there's also something called with grant option. And what that does is it allows the holder of that privilege that has, say you've done grant select on table foo to Bob with grant option. And in that case, the Bob user would be able to then further grant that permission on to other users. So what that effectively does is says, here, you have this permission, but if you think other people need it as well, you can go ahead and just make that happen on your own, rather than, say, having to go back to the DBA for that. And if you were, I could see you might have, for instance, I'm just going to grant, say, select permission on these tables to the manager of the developer group, and then he can worry about which of his developers need further access. With grant option can't be given to public. It has to be given to an actual role rather than just everybody. For those of you who are Unix users, public kind of amounts to the world or other rights. Revoking privileges It's pretty much just the reverse of the grant. Revoke whatever privileges you want or all from whomever you're pulling them from, or public. Apparently, according to the syntax, you can't do a revoke from current user. I'm not sure why the discrepancy is there, but and maybe it's not, but at least as far as the syntax and the documentation doesn't show it. You can also revoke only the grant option, but not the privilege itself. So. Next, I'm going to talk about a couple things that aren't privileges.
Really quick, on the revoking grant options, I can revoke grant on individual permissions. Like I can grant you select and delete, but you can only grant select to other people.
Yeah, although you would have to do that with 2 different grants because otherwise, yeah. Okay. Creating an object is not a privilege of the object itself, which kind of makes sense. We can't grant privileges on an object until it's created. So to create objects, you do need create permission, but you need create permission on sort of the container. For tables, functions, all of those things live inside of a schema. And so what you need to create them, tables and whatnot, are actually create permission on the schema that they're going to live in. So if they're just going to live in the public schema, only someone that has create permissions on the public schema could create objects in public. And the right to create schemas themselves is controlled by the create permission on the database, and I will go ahead and cover that in a little bit. Dropping and altering, and this is one perhaps more surprising, there is no way to like grant drop or grant alter on something. Being able to drop or alter an object that is intrinsic to the owner of the object, and it cannot be granted, cannot be revoked. So the owner of an object can always drop it or alter it. And of course, superusers, database superuser, none of this applies. Database superuser can do anything and everything. This is why you don't want to be logging in as superuser, even if you are the DBA generally. Similarly to, again, a Unix system, even if you're the admin, you normally log in as a non-privileged, non-root account, or I hope you do. And that way you don't accidentally, oops, I did something horrible because I had the permissions and I made a mistake, even though I didn't want to be in that situation. All right, now I'm going to move on. I'm going to talk about each of the objects in Postgres individually and what permissions apply to them. First, we're going to look at tables, and we just saw this. It's what I used for the example earlier. One thing to note is that if you say all tables in a schema, that also means views and foreign tables. Views and foreign tables in Postgres are really kind of just like funny sorts of tables, but for many purposes they are equivalent to tables. And this is one of those. So views and foreign tables then we use this exact same syntax. So you can do grant. I think you can even say grant, say select on table, and then a view name, and I think it actually works. Because Postgres really doesn't draw much of a distinction there. So let's look at each of those individual privileges on a table. There's select privilege, and this allows, if you have select privilege on the table as a whole, this allows select on any single column. Or you can, again, only grant, and I didn't show the syntax for that, but you can grant select only on specific columns. And in that case, you could only do select, and you'd have to specify the column names, and you'd only be able to select from those. Copy to, which is, I don't know for those of you who've used it, what copy to is, it says I want to copy a bunch of stuff from somewhere, like maybe a CSV file or something, into a table. I want to copy the data from the CSV to the table. No, other way around. I'm copying it from the table to the CSV. And that, since you're effectively reading those columns, you also need select privilege to do the copy to. Something to note, say you want a user to be able to update a table. Normally, if you just do update table set, salary equals, 100 million, you're not normally going to want to do that on the whole table. You're only going to want to set one employee's salary to that, presumably your own. But in order to update one row in a table, you're going to need a where clause. So you're going to have to do something like, update, employees set salary equal to 100 million where employee ID equals. And in order to do that where employee ID, that query is going to have to pull the value of the employee ID out as though it were a select. And so in order to use that employee ID column in the where clause of an update or a delete, you need select privilege on it. So if you're giving update and delete permissions on a table, you're almost always going to have to give at least some select privilege as well, just so that they can select which rows they want to affect with those. So whenever you're doing update and delete, also think about select when you're granting those permissions. Let's talk about insert. Insert, amazingly, allows you to insert a new row into the table. You can also grant insert only on specific columns. Those of you, if you recall, if you've used the insert command, presumably it's you do insert, into table, and then you can specify a column list, and then the values to assign to each of those columns. All other columns in the table will just get the default values. So if you allow insert only on specific columns, then they couldn't specify values for the other columns. Let's say you had an invoice table. You probably don't want the person creating a new invoice to say specify the invoice number. You want the invoice number to maybe be assigned by a sequence or something. And so in that case, you would or could control that by saying, oh, they have insert, but not on that particular column. An insert also allows copy from, which is again where you're copying data from, say, an external CSV or something into the table. Again, you're creating new rows, so that needs insert permission. Update is similar, it just allows you to update rows, or again, this can be restricted to specific columns to allow updates to there. And as I noted under select, any kind of update where you're not just updating blanket the whole table, you'll need select privileges as well. Select for update and select for share also require this privilege to some extent as well. Because again, if you're doing select for update, that tells it you're likely to be doing some updates. Delete. Delete allows you to delete rows from a table. And again, since you probably don't want to delete them all, you're going to be needing the select permission to fill out the where clause. Truncate allows you to truncate the whole table. Truncate and delete are two separate permissions. So even if a user doesn't have truncate permission, but they do have the delete privilege, they could delete all the rows by just doing delete from table, and that gives you an inefficient equivalent of truncate. But they wouldn't need truncate permission to do it. Similarly, if they have truncate permission, they could just truncate the table and effectively delete all rows even without delete privileges. So those two are also kind of go hand in hand, and you want to think about both whenever you're allowing either. The references privilege on a table is what you need to create foreign key constraints. So if you have one table that references another table, thereby setting up a foreign key, you'll need to have references privilege on both tables. At minimum, and this is another one that can be assigned to columns, at minimum you need each references privilege on the columns that refer to each other, that are linked together. And finally, on tables there is trigger permission, and what trigger permission allows is it allows the user to create trigger functions. Later, as we'll see, they'll also need, of course, permission. Well, they may need permission to create the function if they're not using an existing function for the trigger. The references in trigger are typically set up at table create time, so I mean, in practice, one rarely affects or adjusts these, but they are there and they are needed. So, next, talk about schemas. Schemas have two permissions. Create and usage, just an example of the syntax up there. All the syntaxes for everything is largely the same. Obviously, though, there's no all schemas in schema because it doesn't make any sense. I do note, though, there's no all schemas in database. So you'll have to do each schema individually. Create privilege on schemas allows you to create new things inside the schema, and I talked about that briefly earlier. You also need create privilege on the schema to rename something. So if you have a table foo and you wanted to rename it to foo2, you'll need create privilege on the schema. And that makes sense because you're creating a new name in the schema. So you need that privilege. You also need to own the table in order to do the alter. Usage on schemas is a privilege which I think of as, again, in the Unix world, equivalent to execute permission on a directory. It essentially allows you to see, and this is all in italics because this is a direct quote out of the docs. It allows you to effectively use the name of the schema to find an object. So you can do select star from, say, public.foo to get things out of the foo table in the public schema. You need usage permission on that schema. Alter schema, and in general, anything to do with altering, you have to own the object in order to use alter. And so altering an alter schema isn't really a privilege. In other words, altering things is not really a privilege. It's just something that the owner can do and nobody else. Same with dropping. Talk about sequences. Sequences have 3 privileges. And a sequence is, for those of you who may not know, a sequence just assigns another numeric value in some sort of a numeric sequence. Just each time you call the next val function, you get the next number in the sequence. And you can also there's a curval function that allows you to say what's the current value or the most recent value that the sequence has handed out. And then there's something called setVal, which allows you to just set the sequence to an arbitrary number wherever you may happen to want it to be. You'll see set sequences a lot if you look at the output of Postgres, PG dump scripts, because in order to restore the sequence, they create it and then it calls setVal to put it into the place it's supposed to be. So I thought I updated that. Ignore the first part there at select. What select does is it allows you to use the curval function to find out where the sequence is at. Update allows the use of both the nextVal and setVal function because those both change the value of the sequence. And usage allows you to use the sequence by finding out the current value and using the next value, which winds up being 3 privileges that are overlap. You can use curval if you have either the select or the usage privilege, and you can use nextVal if you have either the update or the usage privilege, and setVal you must have the update privilege. So there's 2 ways to get at curval and nextVal in terms of granting a sequence or granting permissions, which also means if you do need to control that, you can't just say, oh, this one isn't there, so they can't do this. You'll need to make sure you've got them both covered. Databases, my favorite bugaboo. There are 3 privileges on databases: create, connect, and temporary. But manifestly, what all privileges on databases does not mean is they can do anything. You can't do grant all on database to user foo when you just want the user foo to be able to log into the database and do whatever he wants. The 3 privileges on the databases actually don't do a whole lot. I mean, they're necessary, but the create privilege on the database, only thing it does is allows the user to create new schemas. The connect permission on the database just allows the user to connect. This is checked at the connection startup, and the restrictions in the pghpa.conf must also be met in order for the user to log in. I was happy to discover this when I was putting together my notes for this talk, because in the past what I'd always done if I wanted to lock a user out temporarily, I'd edit the pghpa.conf to remove the access, and then I'd do a pg reload to reload the file. Well, it turns out you don't actually need to do that. You could just revoke inside the database, connect, and then you're not editing a file in the file system, doing your reload and so forth. And then remembering to turn it back. Obviously, you need to remember to re-grant the connect, But you can lock users out just by revoking their connect and then killing their sessions rather than doing the edit. And the temporary permission only allows temporary tables to be created. So the three of these are certainly all necessary to normal usage of the database, but they're not a blanket catch-all to set up a user to kind of have full access. I bring that up because I've seen 2 people do that at places I've been working at, or attempt to, and then being confused and coming to me asking why that didn't work. Types and domains. For most purposes in Postgres, types and domains are the same thing, and so I'm going to talk about them together. There's only one privilege, which is use. And what using a type or domain means, it just means that you can't or can create objects that use the type. So if you have a custom type in or any type really, in Postgres, and you want to create a table that has a column of that type, you have to have usage privilege on the type or domain. You could still construct literal values of that type if you wanted to, even without usage. I mean, you could do like select, cast a value to that type and get that type back. That doesn't prevent that type of use. It just prevents you from creating things that, if you tried to drop the type, would break. Foreign data wrappers. I'm not going to talk a whole lot about these. Foreign data wrappers be an entire talk or probably even half-day tutorial on those. But the usage privilege in foreign data wrappers just allows you to create new servers that are using that foreign data wrapper. So, if you have the Postgres foreign data wrapper to make a connection out to another Postgres thing, just to create that server definition, you're going to have the usage privilege. And similarly for foreign servers, once you've created the foreign server and the foreign data wrapper, the usage privilege there is what you need in order to create those foreign tables that reference that external data source. The usage privilege on that also allows a user to muck about with his own user mappings. Again, I'm not going to talk about that in any great detail. It's far too long. Functions. Functions have, again, only one privilege, which is execute, and that allows the use of the specified function. But the other thing that execute privilege on a function does is it allows you to use the operators that may be implemented that function. In Postgres, every single operator is implemented by some function. Most of the ones, if you do select 2 plus 3 to get 5, that's built into Postgres. It comes with, but that plus underneath is implemented by a function that knows how to add 2 integers. And so when you call 2 plus 3, you're really calling that function with the 2 arguments. And you need execute permission on the underlying function. It would probably be daft to revoke that permission on something that's built in from somebody, but I mean, in principle, you could, and you need that thing, that privilege. And like most of these you see, for instance, you can do, grant execute on all functions in a schema. Languages, and by what we mean here is the procedural languages, PL, PG, SQL, PL, Perl, and so forth. In order for a user to be able to do a create function, language, SQL, PL, PG, SQL, PL, Perl, in order to do that, they need usage permission on the language itself, just to create the function in the first place. Now, obviously, in order to create a function, you need to create on the schema and so forth to create the new object. Tablespaces. For those who may not be familiar with tablespaces, tablespaces are just a way of naming. Normally, Postgres stores all of its actual underlying data files on the file system, the operating system, in one place in one directory. What tablespaces are is a way to give a name to some other place on the disks. And in order to put things in those other places on the disk, tables, indexes, temporary files, and so forth, you need create permission on that tablespace itself. Create permission on a tablespace also allows you to set up a database that just says, hey, by default, I want everything to live over in that part of the disk instead of the default part that Postgres normally uses. So that allows both. If you revoke this privilege, that does not move things from the tablespace that they're already in if they've been put there, nor does it make them inaccessible. It's just merely the ability to put them there in the first place. If you do want to move them, that's an alter tables, set table space, and so forth. And like any other alter, you would have to own the table to do that. You would also need create on whatever table space you were moving them to, because you're putting something there. Large objects. Large objects are sort of their own little thing in Postgres, but where you just have a big chunk of data and you don't want to store it within a column as a byte A, but treat it as a separate thing, but still have it within the database. You can use a large object. And there are two permissions related to large objects, which are select and update. And much like a table, select allows you to read from the large object, and update allows you to either write to or truncate. I assume, and the docs weren't clear on this, but I'm pretty sure that in order to drop a large object entirely, you would have to be the owner, much like dropping a table or any other object. That is all that I have about, and those are all of the privileges on all of the tables, or rather all of the different objects in Postgres and approximately what they mean. The next thing I'd like to talk about are setting up and creating read-only users, these permissions. A lot of times, when I'm out somewhere, I frequently get the request to, we need to let the developers onto the production database. After I get done panicking, and hopefully I can talk them into, let's just give them read-only access to the production database. So at the very least, they can only bring it to its knees by issuing bad queries, not actually wipe out production data. So when we say a read-only user, what do we mean there? Well, basically, we don't mind so much if they create little writes, temporary tables, that kind of stuff. What we really don't want them to do is modify any of the data or any of the DDL. We don't want them to like drop a table, create it, add a column to a table, create a new index, that kind of stuff. Functions, though. Functions, of course, can effectively do anything. I mean, they're called with a select, but inside the function, I mean, they can make whatever modifications the code calls for. But it turns out if they're not security definer functions, that's okay, because whatever the function tries to do will execute, run with only the permissions of whatever user has called the function. So it's okay to let them run functions as long as they're not security definer functions, and I'll talk about those in a minute. So we also noted that non-privileges, one of the non-privileges, the owner of a table can always drop it, alter it, and so forth. So in order to be read-only, that read-only user can't own anything in the database. They must not be the owner of any object, because the owner can largely do what they want. So to create a read-only user, we need to give them select permission on every table, and that is made easier by doing the grant select on all tables in schema, and you'll have to issue that for each schema. They'll need select on all views. Again, those are largely like tables. They'll also need select on all foreign tables, which I don't have listed here. They'll need select on all large objects that may exist so that they can get at the contents of those. They will need select on all the sequences, but as we noted, make sure it's not update or just usage, because usage will give them next val as well. They'll need execute on all the functions. They will need usage on all the schemas just so that they can find things within the schema. And finally, they'll need connect on database, of course, because, well, they have to be able to get in to do anything at all. And that's pretty much it. The hardest part of doing that really is just to make sure you get a good schema list. And there's ways you can query the system catalogs to get those and automate your scripts. But the biggest thing is just make sure they have select on everything, execute on functions, usage on schema, connect on the database. Go ahead.
So when you grant execute on functions, that is kind of writable.
I'm sorry, say again?
I said when you grant execute on functions,
Mm-hmm.
that can be damaging.
Not unless they are security definer functions, because a function normally just runs as with whatever privileges of whatever user's running it, regardless of what the function says. I'll talk about security definer functions in a minute, and I'll cover that in a little bit more detail. I want to talk about inheritance. As I noted earlier, Postgres doesn't draw a whole lot of distinction between a user and a group. And so here we have some syntax, and you'll see we have grant role name to role name. So we can grant Alice to admins, for instance. And that, and both admins and Alice would be roles. So you do like create role Alice, create role admins. And then later you can do grant Alice to admins. And what that means is that when Alice is logged in, Alice will, in addition to having the permissions that have been granted to Alice, will also have all of the permissions that have been granted to admins.
The other way around. Grant admin to Alice.
Ah, yes. Yes. Thank you. Yeah, so grant admins to Alice, and that makes a lot more sense, means that Alice will run with, in addition to anything that, say you did a grant select to Alice on table foo. So then Alice can do select foo from table. If you do grant update, insert, delete on foo to admin, then if you've later done grant admin to Alice, Alice will be able to do inserts, updates, deletes, and anything else. The advantage of doing this, the primary advantage of doing this, is you can centralize your management a little bit. So if you have 5 or 6 DBAs, you don't need to grant each of them whatever permissions they need. Well, DBA probably needs everything, but instead you can just grant all those permissions to admin, and then later if you have Alice and Bob as both of your DBAs, you can just grant admins to Alice, grant admins to Bob. Later Alice resigns, then you just revoke admin from Alice, and you're done, because they will no longer have those permissions. They're no longer a member, as we call it, of that role. With admin option on this is similar to the with grant option earlier. If I grant admin to Alice with admin option, then Alice can later go grant admin to Bob. And it basically allows Alice to re-grant those re-grant that role membership to somebody else. Again, this might be useful to do, say, for your developer lead. So earlier I had setting up a read-only role, and I would recommend, or rather I had how to set up a read-only. I would recommend actually not granting all of that process to whatever users need, but instead do create role read-only, and then do all of those grants to that read-only role. Then later you have, developer Joe needs access, and you just go grant read-only to Joe, and you don't need to worry about Joe specifically, because he'll just pick up all of those roles by inheriting them from the read-only role.
Is there an easy way to see what all the roles that have been granted to Joe are? Show me what Joe, every role that Joe has inherited.
There is, and I don't recall what that easy way is. Steve, do you remember?
PSQL backslash, even PSQL would be just
DU.
backslash DU should give you that. It's over on the right is the list of roles that have been granted to that. Now, what that doesn't give you is the whole tree of roles, right? For that, you can write a recursive query that goes again and give you all numbers.
Okay,
Sure.
but if I
Yeah.
want the recursive rules, I do have to manually query.
Yeah,
There's no magic button.
No, there's nothing in PSQL today. We could possibly add something if it had been.
To that as well as something I want to note that these sort of cascade. So you could, if you had read-only and read-write, you could, it's kind of a contrived example, but you could grant only the write permissions to the read-write role, and then grant read-only to read-write, and then grant read-write to admins, and then grant admins to Alice, and Alice would wind up getting all the stuff to admins, which might even be nothing, all of the stuff from read-write, and all of the stuff from read-only, because it would inherit right on down the chain. And users can be members of more than one role. You could also grant read-write, or read-only and read-write to admins. You could do it that way as well and have a forking tree instead of a cascading one.
No loops though. Loops are bad.
Yeah, that would probably be bad.
Yeah.
Would it prevent it?
Yeah.
Okay,
Yeah.
it will prevent it.
Can't do that.
Alice is
it's owned by Alice, and yeah,
That seems bad.
it's obnoxious, I know. I don't disagree with you, but unfortunately,
You can prevent that though if you, Alice would have to do this deliberately, but if you have like multiple role memberships, you can do a set role and then the table will be owned by that. So Alice could do set role admins and then do the issue the table create, and then it would be owned. Alternatively, Alice could create the table and then do alter table owner to admins. So it could either set the role and get it by default, or they could Alice with that membership set could do the issue that alter table.
Is that the difference between the session user and the current user? In that you set, sorry,
Largely, yes.
like when I set role, I'm changing the current user, but not.
Yes.
Can you also set up so that the roles don't automatically inherit?
You can.
So they have to do a set role to get that?
Yes.
Yeah, you need an intermediate role with the no inherit flag set.
Yeah. When you create when you create the role, you can create that with the no inherit, and that basically will make it so whatever permissions they have don't automatically roll down the line. So that yes, then you would have to explicitly do a set role. And again, this you might even want, for instance, if you're granting admin to a role, to have the admin not inherit, so when they log in, they don't automatically just have everything. Rather, they have to explicitly do a set role to, kind of let the database know, hey, I'm going to want to start to be modifying some stuff now. Let me talk about security definer functions, which will get, I believe, to your point or question earlier about executing functions and whether that's dangerous or not. You'll see down the middle of the huge syntax for creating a function where it says security definer or security invoker, just above cost and just below called on null input. So when you create a function can either be a security invoker, which is the default, or a security definer. And a function that is a security invoker function runs with the user that calls it. So if, say, our developer Joe, who only has read-only access, calls the update and blow away all the old invoices function, for maintenance, it'll just fail because it'll get through to where it tries to run its updates or deletes, but those will still run as the user Joe because the user Joe is the one who called that function. So those will fail. In other words, a function doesn't get you any more privileges than you already had, except if the function is called, or rather created, as a security definer function. And a security definer function or security definer functions, those execute with whatever privileges of the user that owns it. So if our DBA Alice creates a function that, again, let's say that we have a table with our developers and has their phone number, contact information in there, and along with a bunch of other stuff. And we want the developers, for instance, maybe to update their own phone contact info or maybe on-call info. Alice could create a function that took, say, a new phone number and updated that table, create that as a security definer function, and then that function would then run as Alice and be allowed to do the updates. And that's safe because Alice wrote it and she knows the only thing that this does is this one update that we want to allow the developers to do. But that doesn't, since it's a controlled set of code, and obviously a security definer function, you have to audit and be very, very careful because it's not going to run, in this case, as Joe. It's going to run as Alice with all of her permissions inherited down from read writes, admins, and whatever else you happen to have. So security definer functions are essentially a way to encapsulate, or at least their main purpose is to encapsulate a very small piece of privilege that would be difficult to do with the privileges themselves, because it might need to, I need to select from these two things. One could come up with, obviously the examples are going to depend on your business case, but the security definer functions allow you to create those functions that run separately.
What
The default is the security invoker. The default is no extra privileges, or rather, it just uses the privilege of who executes the function. So if by default, if we create a function and we haven't said anything, it's security invoker, and then when Bob runs the function, it'll run with Bob's privileges. When Alice runs it, it'll run with Alice's privileges. When Joe runs it, it uses Joe's privileges. Security definer is the way to get around that so that it always runs with a defined set of privileges, which are the table owner. If you go through the docs, we'll probably get this fixed soon, it says that they run as whatever user created the function. It's actually whatever user owns the function. Postgres doesn't even keep track of who created it. So, and like other alters, the owner of the function could be changed by a super user with alter function. If so, you can create it and set it later. Go ahead. I think the owner could change to another owner if they're a member of that. They'd have to be a member of both the owning role and the target role, and I think that's all they would need. So,
the target role also has to have create privileges on the schema.
Yes. I might even have said that earlier, but yeah. So in this case, for instance, like with our example, if we had granted admin to Alice, Alice could create a function and then change the owner to admin if we wanted to. Again, provided there's also create permission. There's a set of default permissions that everything has. The general rule when you create a new object, it has a certain amount of permissions to begin with. And by default, those are the owner has every permission, public has none, nobody else has any. With the following exceptions. Public automatically or by default gets connect permission and temporary permission on a database. So other users can log in and connect. When you create a new function, public gets execute. So you create a new function, by default, public can execute it. And as we've sort of been discussing, that's okay because they don't otherwise have any other permissions that you haven't given them, and functions don't get you extra privileges as such. When you create a language or a new language, by default has usage privilege. So if you have a language, you install PL Perl, PL Python, whatever. By default, users will be able to create functions with the language. But of course, in order to create the function, they need to create permission on the schema. So again, by default, that isn't really getting them a whole lot. And types and domains allow their usage, which again is just the ability to, say, create a table that uses a type.
Tablespaces don't have any defaults.
I'm sorry?
Tablespaces, they are by default.
No. Not by default, there's no, well, the owner of the tablespace has the create permission, but public does not. So in order to allow, if you create a new tablespace, if you want a user to be able to put stuff there, you'll have to explicitly grant that permission either to the user or to public. We talked briefly about changing default permissions because we have the defaults here, which are all the owner and none of the public, but you can change that for either a role and possibly only for objects in a particular schema. So for instance, the main use I think of this is you may wish to do something like alter default privileges for role read-only in schema public, grant select on tables. So that way if you later create a new table, read-only will get the select without having to re-up the commands.
You have to do alter default privileges for the creating role, and then you do the in schema grant select read only.
Yeah, read-only is the grant target. The applicable role is
Oh, sure.
Yeah. The role
Okay.
creating it is the one you're doing the for role to the target role.
Okay.
The role that's creating objects, right?
Yeah. Oh, yeah. Okay, so for whomever then
Yeah, whoever's creating.
creating, then grant to public.
I think got it backwards at least once.
You can only alter the default privileges for tables views, foreign table sequences, functions, types, and domains. It also, when you alter the defaults, it doesn't change permissions on anything that's already been created. It's only future stuff. You can look at them if they've ever been modified with the \DDP, which is similar to the \DP command. That's about all I have. I might have time for one or two more questions, although we've taken some during.
We have one, but you get time for a minute.
Yeah. Yes. Go ahead.
So then you have the grant all and all the columns of the table.
Mhm.
Can we exclude only columns? Because when you are having the grant all on the schema,
Right.
all the tables, just I want to exclude one or two columns on those tables.
No, you would have to, basically, it's sort of the merging of all. So if you've granted select, for instance, on the table and granted select on some columns, they're going to be able to read them all. But I think you could revoke from just a column. You might have to, no, I don't think that, yeah, I think you would have to not grant select. You'd effectively have to grant, you don't grant select on the whole table, grant select only on the columns that you want them to use. Because otherwise you'll get the union of all. Effectively, whenever there's sets of permissions, the user has the union of all the permissions that have been granted.
I was looking at when you have a big table with so many columns, which is one where I go for this table. So
That's when I write a script to troll through the system catalogs. So, any other questions? All right. Well, oh, sorry, there is one.
Not so much a question, a comment. There's one kind of fun thing that can happen with security-defined functions and foreign keys. Foreign key functions that get defined and created behind the scenes are security definers. If the owner of the table has somehow lost, for example, usage on another schema where the referred to table belongs, even a super user can't do the foo that makes the that makes the foreign key trigger get fired. I don't know if anybody's ever seen that before.
I have.
Fell out of me for a few seconds.
Yeah.
Well, I mean, that's true for any security definer function. Even if you call it as a super user, it will run as the user who owns the function.
Right.
Right? And that user may not have privileges, and you're right, that happens for foreign keys.
Sure. In this case, you have to remember that foreign keys are triggers too.
Yeah.
And they get created behind the scenes without any of your knowledge, but they are security definers.
Yep.
So just for what it's worth.
All right, everyone. Thank you for coming. I hope you all got something out of that.